something to give the installation of the OCP or something, or it will come later?
No, installation is not covered in this course. Okay.
Okay.
Because if you want to install OpenShift, actually you need very high resources. Plus, it is an enterprise product, so we need a subscription to install that. Okay. But by default, you have already registered for the role, so Red Hat will actually give you the complete setup to practice.
Understand.
Okay, so we cannot install it here. But yeah, you can install CRC, code ready containers. Okay. This is the mini version or a single node cluster of OpenShift. Clear?
Okay.
Like we were using Minishift in the OpenShift 3.9. We were using Minikube for Kubernetes. Okay.
Right.
Like that, OpenShift 4 actually provides you the feature of CRC. It is a single node cluster. You can install it now. Now let's go with the chapter now. Introducing OpenShift Container Platform. So we've already discussed about what exactly OpenShift is. So Red Hat OpenShift actually provides you an enterprise-ready Kubernetes environment for building, deploying, managing container-based application in any public or private data center, including bare metal servers. And RHOCP is compatible with multiple cloud and virtualization providers. Now, one is Red Hat OpenShift Dedicated. So provides a managed OpenShift environment in public cloud such as AWS, GCP. This product provides all the features that RHOCP provides. However, Red Hat manages the cluster for you. Okay, so one is this, you can install by yourself on the bare metal also. And one is you can purchase a Red Hat OpenShift Dedicated. So the cluster, it is a managed OpenShift actually. It is managed by the Red Hat itself. Okay. Now, one is Red Hat OpenShift Online. So you can use Red Hat OpenShift Online also. Okay. There's a website try.openshift.com. Here on your computer, if you want to set up in your data center, if you want to set up self-managed and managed service installed and maintained for you, but you have to give the charges. You can try it. This is the product, fully managed. Request information. So Red Hat person will contact you and will like share you the prices and all the things. Clear? And if you want to use on your laptop, this is about the CRC. CRC. But for that, I need to log in. Now, see, you can select your operating system. You can download code ready containers. It is of 2 GB. Okay, and all the documentation is given over here. But one more important thing, if you want to set up it on Windows, then your Windows should be Windows Pro or Windows Home, but with Hyper-V enabled. So Hyper-V Manager and all should be activated. Okay. But if you are using a Windows like a normal version, then you will not be able to use code ready containers. For that, you need to install the Linux on the base machine. And after that, onto that Linux machine, you need to install a VirtualBox. And in that, you can use code ready containers. Now,
sorry, repeat what exactly the prerequisite for that?
Windows Pro.
Red Hat code ready containers. What it exactly means?
It is a single node cluster for OpenShift.
Okay, single node.
Yes, one node will be treated as master and the worker at the same time.
Okay, you are saying the CRC, right?
Yes.
The code ready containers. Okay.
Yeah.
So
now
we can install on our laptop with the on the window laptop with the condition is that we need to enable
Windows
the Hyper-V, correct?
Windows
Either
Pro you need. Yeah, Hyper-V enabled.
In a normal home edition as well?
No, in Home Edition, I have tried to install, but it was not giving the privileges to install.
Okay. Okay.
Okay. Yeah. And this is the complete services and features. So you can install OpenShift on physical, virtual, private, public cloud. This is using Linux. For the container runtime, it is using CRY-O. Okay, it is actually giving you the Multus SDN already set up for you. It is already giving you the storage, means internal OpenShift registry also it is giving you. For the logs, it is giving you ELK. For metrics, it is giving you Prometheus. For security also, the OpenShift gives you a lot of things like SELinux is enabled in this cluster. Okay, and there are some new concept of SCCs and service accounts. Okay, so we will discuss that in chapter. Now, for the container orchestration and cluster management, it is using Kubernetes. For application lifecycle management, it is giving you S2I. Okay, for build automation also S2I, and deployment automation also S2I. After that, service catalog, where all the different type of builder images are provided to you by Red Hat, and they are also supported by Red Hat. And the self-service web console is given to you. From that, you can manage complete cluster. So OpenShift actually runs on top of Kubernetes and Docker or CRY-O. So CRY-O engine, Kubernetes, self-service web console, number of pre-installed application like internal registry, monitoring framework, and certified container images for multiple programming languages runtime, databases, and other software packages. Now, what are the features? One is high availability. Kubernetes has been designed with high availability in mind, but for both internal components and user application. And a highly available etcd cluster stores the state of OpenShift cluster and its application. That is same, but in terms of OpenShift, if I talk, then OpenShift gives you a cluster autoscaler, okay, which is new, but in Kubernetes, you need to configure that by yourself. Okay, so it gives you the pod level high availability also, and node level high availability also. Pod level high availability is maintained by replication controller or replica set, but the node level high availability is actually controlled by the node controller or the cluster autoscaler or the machine controller. Okay, now lightweight operating system, we have already discussed about RHOCP runs on Red Hat CoreOS. So it is a lightweight operating system that focuses on agility, portability, security. And this operating system is immutable, means entire operating system is updated as a single image. This we have discussed yesterday. Now, RHOCP controls updates to RHEL CoreOS and its configuration. And so managing an OpenShift cluster includes managing the operating system on the cluster node. So it is actually freeing the system administrator from this task and reducing the risk of human error. Okay. Otherwise, in the Kubernetes, if you want to update the OS, you need to go on each worker node and you need to run yum update command by yourself. And maybe there is a possibility that while updating your operating system, some of the pods can go down. But Red Hat OpenShift is using Red Hat operating system, and which is CoreOS, and it actually updates as a single image. So no need to worry about that. Okay, so OpenShift has free system administrator from these tasks. For load balancing, it is actually giving you HA proxy load balancer for external access to application that is already configured inside the cluster. In Kubernetes, you have to configure the ingress by yourself. Okay, but in OpenShift, it is already giving you HA proxy, which will actually manage the load. Okay, it is a URL based load balancer. Layer 7. Okay.
Sorry, can you explain this load balancer again? Kaushal?
It is giving you the HA proxy as pre-configured. Okay. It is a layer 7 load balancer, URL based load balancer. If the request is coming on.
You're saying that HA proxy is the inbuilt proxy is given by the OpenShift, right? As you are saying, right?
But in Kubernetes, you do not get it. You have to configure it by yourself.
No, yeah, the Red Hat is also not giving this here. They're charging extra for that.
What? Yeah, what? What are you saying, Manish?
I'm saying that the Red Hat is not giving the by default HA proxy load balancer, software load balancer with the solution.
No, this is not. I'm not talking about the external load balancer. It is an internal load balancer.
Okay. This is internal load balancer. Okay.
Yeah.
And it's Manish, it's the application level load balancer, software based
Yeah,
load balancer.
URL based means application load balancer inside the cluster.
Okay. Got it.
Okay.
Sorry. Right.
Now, like it is using route, which is using HA proxy. In Kubernetes, you configure ingress. Okay. And that ingress is actually using Nginx reverse proxy. Got it? So ingress is treated as route in the OpenShift. So route is using HA proxy, ingress is using Nginx. For automatic scaling, so OpenShift clusters can adapt to increased application traffic in real time. Why? Because see, to do automatic scaling, you need the CPU and the memory utilization of the nodes, right? Without having the CPU and the memory utilization from the node, I cannot perform automatic scaling. Because how I will calculate my load? Okay. So in the Kubernetes, you do not have that feature. You have to configure it. But in OpenShift, it gives you Prometheus. So Prometheus will automatically give the data about or the real-time data about the CPU and the memory being used on the worker nodes. And on the basis of that, OpenShift has a power that it can automatically scale your application. Even it can automatically scale your worker nodes. Okay. This type of facilities are also given in OpenShift, but this is not available in Kubernetes by default. You need to configure it. Logging and monitoring, so it gives you ELK, and with the help of ELK or Prometheus, you can have hundred of matrices about your cluster. Service discovery, that is something like a core DNS. So Kubernetes also gives you the internal core DNS. Okay, so from a pod, you can discover some service. Okay, generally what happens, every pod gets an IP address. But let's say if you want to connect one pod to another pod, then you need to mention the IP address. Then the IP address is dynamic thing. It can change. So to give you the easy setup, what OpenShift is giving you and what Kubernetes is giving you, they are giving you an internal DNS, which is only configured for Kubernetes services. Okay. So pod will always get a name, and with that name, you can contact the pod. Okay. It's something like if I want the IP address of Google, I can use nslookup www.google.com. I don't need to remember this IP address. So this is how you can also nslookup the pods. Okay, and it will give you the IP addresses. For that, they have managed the internal DNS server. Now, storage. So now one very important point we are going to discuss over here. Let's say you are deploying Kubernetes on Amazon or on some server, and you want some storage, you want some external storage. Now, what you will do, you will configure the EBS by yourself, you will configure the S3 by yourself. After that, you will create persistent volumes. After that, you will create PVCs. After that, you will mount that PVC inside the pod as a volume. Okay. These all the things are manual. But when you are actually installing OpenShift, OpenShift has a power to provision the storage for you. If you are installing OpenShift on AWS, it will automatically provision a EBS storage for you and automatically configure everything inside the cluster, okay, to serve your application, that is storage. So that is
Kaushik,
something OpenShift has.
my query related storage is basically Red Hat is giving the solution for the storage is OCS, OpenShift containerized container storage, right?
Mm-hmm.
So by default, when we installing a RHCP, so that we need to install OCS along with that, or we need to separate OCS installation.
If you are using full stack installation of OpenShift on AWS, then it will automatically provision the storage for you. But if you are installing the OpenShift on bare metal, then you have to configure the storage by yourself.
So OCS will installed on the specific storage boxes, right? On the top of that.
Yeah.
How is that?
Let me search it. I'm not aware about the OCS. What you're talking about? OCS OpenShift.
कुशाल स्टोरेज क्लस्टर स्टोरेज यूज करता है रेड या सेपरेट यूज करता है?
See, it depends on you. आप किस टाइप का स्टोरेज यूज करना चाहते हो. Okay. I'm just saying that अगर आप if you are installing the OpenShift with the help of full stack automation, and if you are using full stack automation installation on AWS, then OpenShift has the power to create a EBS storage for you automatically on the AWS. Okay. So it actually embeds a number of storage providers that allow for automatic provisioning or storage on popular cloud providers and virtualization platform. So cluster administrator do not need to manage the fine details. Now, if you are installing the OpenShift on bare metal, then you have to configure everything by yourself. Now, it depends on us, okay, what storage type we want to use. Okay, you can also use OpenShift with cluster FS. They have given you everything over here using cluster FS, configuring persistent storage. So persistent storage always depends on you what you want to configure. But if you are using AWS and if you are using a full stack automation, then it will automatically select the persistent storage as EBS. Got it? Clear? This is clear? Manish, Ashish, Nagi?
You are searching for OCS, right?
Yeah, OCS is a different thing. Okay, I am not aware about this OCS, OpenShift Container Storage.
Okay.
Okay, because I've never used it. Okay, I'm just seeing this. You have just told me a new term today. Thanks,
Okay.
by the way.
Okay. No. This is the basically storage solution is like a SAP cluster storage, which
Okay, so
will
SHAP is a product of Red Hat, so they must be
right
giving you some cluster storage over here.
right. So this storage is will provide the three type of storage, basically file system, block storage, and the object storage.
Okay, so for the file storage, what they are using?
Uh, they are
For the
using
block
the file
storage, they
system.
must be using some,
The,
I think
Rados gateway.
EBS.
They're using the base same as a SAP cluster, like a Rados gateway for that.
Okay, got it.
For the object storage, for the block, they are using the RBD.
RBD. Okay.
Yes.
Okay, maybe. So this is a new facility. Great.
Okay.
Now, in the application management, it is actually using the source to image feature to automatically build containers based on your source code and run them in OpenShift. And the internal registry stores application container images which can then be reused. This decreases the time it takes to publish your applications. Now, and it supports many runtime languages like Python, Ruby, Java, Node.js, a lot of builder images are there. Cluster extensibility. So there are a lot of extensions which is given by OpenShift to you. One is OLM, Operator Lifecycle Manager. Okay. Now, guys, are you aware about Operator? Nagi, Manish, or Ashish? Do you know
No.
anything about Operator?
End user, like not end user, use management operation, like daily operation.
No. Can you please explain? I'm not. I heard about that, but I'm not remember right now.
See, let's say this is your Kubernetes cluster, Manish. In this cluster, you are running 3 pods. You want to run 3 pods. Let's say on Sunday, you want to backup of all these pods data. Do it. Obvious manually. Now, for this particular operation, we have created a resource, a custom resource. and named it as MySQL management. Okay. And we have programmed it, which is a little bit tough. Okay. Generally, there are a lot of operators are already available. Operator is a custom resource, which gives you some extra functionality. Okay. So for MySQL management, you have a custom resource or operator. So this MySQL management will actually handle the MySQL. With this MySQL management, you can create users, you can create groups, anything. Like the way you do with replication controller, RC. RC is what? RC is a resource. And this resource give you what capability? Anytime you can increase the replicas, right? If the RC was not there, obviously you need to create the pod by yourself again and again. But someone has the idea and someone has written the code for RC, and that RC is giving you the functionality. If you want to use these type of custom resources, then that are called operators. Okay, got it, the concept of operator?
Basically, what I understood from you that if you want to do some automation perspective or what exactly betterment of this setup, you can call it as a one of the operator, right?
You can call or you can create your custom resource. Okay, let's say right now in your OpenShift, in your Kubernetes, we have discussed about the pod, right? We have discussed about the deployment also. So what we write? These
Right.
pod, these deployment are what?
These are
Resources.
resources.
And this deployment has been written by some developer.
Right. Absolutely.
Obviously, and that deployment is doing what? It is giving you the functionality to do a rollback and the rolling update. Like,
correct.
now,
Right.
like this, I have created one more resource as Manish. This resource will actually manage the backup of all my MySQL pods into my cluster.
Okay.
Got it? So this is what a operator, because it is a custom resource. It is not
So
by default available, but you can
if
create it or you can download it from internet.
okay, so these are easily available, or the developer is working on the operator side as per the use cases. Is it?
Yes. And there is a operatorhub.io.
Can you please show that one of the examples that how?
See, let me search for database. So these are all the different type of operators. You can use it within the Kubernetes also. Database, these are the databases. Let me go for MongoDB. Now see, this is a MongoDB operator. So this is a resource. Now let me tell you the YAML. MongoDB deployment, MongoDB user. See, MongoDB user is a resource. And what this DB user will do, this particular resource is going to create users in MongoDB, right? Second, I have this also, this resource MongoDB. So this MongoDB resource will actually manage the replicas or everything of related to my MongoDB, right? This is about the MongoDB operation manager. One have created the resource for this also. So it will manage the version, credentials and everything. Okay. So these type of custom resources are created by the developers.
So what let see this MongoDB deployment, right? This is the same deployment we are saying kind is equal to deployment, right?
Yes.
Right. So just he created for that specific MongoDB only, correct?
Yes.
Not basically the base is the same deployment, or but they have added the naming. They are renaming with the specific with the name, right? You can say like that.
They have no. You
Or
will
adding
create the
their
deployment of
respective
MongoDB. You will create the pods. But if you want to create some user in that MongoDB, you can use this YAML.
Understand. I'm rephrasing my query again. So what we seen in Kubernetes, but you said that in the Kubernetes deployment, we are deploying the Nginx 1.18, right?
Yes.
Okay. So if you want to deploy again 1.19, right? So we need to deploy again with the 1.19, right? again.
Yeah. Yes.
Okay. So whatever, if let's suppose as a my production, okay, I want to deploy Nginx and I want to add specific user in that, right? I will
Yes.
create my own operator deployment for the Nginx, right?
Yes.
So that way called as a custom operator.
Yes. Custom resource, which is called operator.
Custom resource which called as a operator.
Yeah, because we are creating the resource of on self or self, no?
Just we are customizing, or we can customize
We are
our
adding some new
deployment.
features into the cluster.
Okay.
Okay. Now, let's say there is no functionality like operator. Then every time you need to log in into the Nginx pod and you need to change the deployment, right? And you need to create the users by yourself, Manish?
Correct. So one of the but just one of the use case where we're normally doing by any application want to run on that part. Is the basic, correct?
Yeah. Now let's say for the security also, for the storage also they have given you AWS S3 operator. So AWS S3 operator will deploy the AWS S3 provisioner, which will dynamically or statically provision AWS S3 bucket storage and access. And this operator deploys the object bucket claim, custom resource, everything. Okay. Why we create replication controller? Because it can automatically create multiple pods at the same time.
Correct.
So that's why you are also given with the AWS S3 operator. So these are the custom resources which are giving you some extra functionality. Okay.
When let here he mentioned the exactly kind is equal to storage class. Okay. So
No, don't go for a storage class. A storage class is a concept of Kubernetes in OpenShift. That is a pre-installed resource. Okay. This is
but
object bucket claim. Got it? Clear, Manish? This is object bucket. Object bucket.
I'm trying to visualizing something. So, Kaushal,
Like
so
this is the pod.
what I understood is that when you taking example of that AWS S3 operator, right? So, my understanding of the AWS S3 is a S3 is a storage integration of that for the object storage, right? Is it right?
Yes. So this
Okay.
operator will deploy the provisioner automatically.
So let's suppose my setup is running on the on the AWS RHSP, right? On the top of AWS, right? So I want to use I need some storage, object storage. So I will need to run the container for S3, AWS S3 to fulfill my storage requirement. This is the exactly use case. So on that.
No,
Sorry.
Manish. See, this is your Kubernetes cluster.
Okay.
And let's say you want to provision a persistent storage of S3.
Okay.
What you will do? You will go to AWS.
Right.
You will create a S3 bucket.
Okay.
You will create the classes, whatever are required for that S3. Okay. And after that, you will attach it to cluster, right?
So yes. So my
So
last step is
to do this
last step,
only,
last step
you
is
have
easily to attach with my OpenShift cluster. This is the last step.
yeah. These are the steps. Now
Right.
these are the steps for these steps. Now see, let's say you have 10 clusters. Every time you need to do this step by yourself. So you have created a particular resource for AWS S3, which will do these steps for you automatically. Okay.
Sorry, Kaushal, I'm again asking the question. So is that possible? Let's suppose I am running the OpenShift on my bare metal. Okay, only OpenShift. My master node is running on my open bare metal. My worker node is running on a bare metal.
Yeah, you can create a resource, Manish, of AWS S3 over there, and in that resource you can give your credentials and everything, and that particular resource can actually provision the storage for you automatically.
Kaushal, I think I'm. Just listen my query again. Then
मैं समझ गया आपकी बात. Let me tell you. Okay.
Okay.
जैसे Negi, I'm just right now. I'm just for 5 minutes. I'll speak in Hindi. Okay.
Okay, sure.
Yeah. जैसे ये pod है मनीष. Okay.
Correct.
अब इस pod की हाई अवेलेबिलिटी मैनेज करनी थी तो मैं ये भी तो कर सकता था कि मैं बार बार Kubernetes क्लस्टर पे जाता, बार बार kubectl get pod देखता और बार बार मैं देखता कि pod चालू है कि नहीं चालू है तो वापस मैं क्रिएट कर देता. राइट.
Correct.
अब ये मुझे करना था, इसके लिए मैंने क्या किया, आरसी बना दिया और आरसी को मैंने ऐसे प्रोग्राम कर दिया कि वो बार बार जाके देखेगा और उसे लगता है कि कोई भी पॉड डाउन हुआ है तो वो ऑटोमेटिक क्रिएट कर देगा. राइट. अब क्या करना था, क्लस्टर के साथ मुझे S3 का एक बार बार मुझे जरूरत पड़ती है, हर 10 दिन में मुझे एक S3 का स्टोरेज प्रोविजन करना पड़ता है मेरे नए क्लस्टर के लिए. तो बार बार मैं अमेज़न पे जाता हूँ.
Now you explaining the functionality of RC that I know. But now you are saying that specific RC explanation for the AWS RC file, right?
Yes, जैसे AWS है. अब बार बार लेट से आपको हर 10 दिन में मैनेजर नया क्लस्टर देता है, आपको बार बार S3 पे ऑब्जेक्ट स्टोरेज प्रोविजन करना पड़ता है, बार बार आपको बकेट बनानी पड़ती है, बार बार आपको रूल्स लगाने पड़ता है. ओके. ये सारा काम आप मैन्युअली करते हो.
अंडरस्टैंड. नहीं, इसमें मुझे कोई डाउट नहीं है. वो आप जो कह रहे हो आई कंप्लीटली अंडरस्टैंड. माय क्वेश्चन इज वेरी ऑन द डिफरेंट वे. ठीक है, वो आगे जाके जब स्टोरेज पढ़ेंगे देन वी विल आई आस्क द क्वेश्चन. नो प्रॉब्लम, वी कैन कंटिन्यू
ना. अगर आपका क्वेश्चन इससे डिफरेंट है देन मुझे बताओ.
हाँ, इससे डिफरेंट था. मेरा क्वेश्चन ये था कि मेरा जो था कि जो आप S3 वाला एग्जांपल लेके आए, व्हाट यू शोन इन द AWS S3 operator, right? But exactly the use case I want to understand. That's why I'm digging into that part. उसमें क्या था कि मैं ये समझ पा रहा हूँ कि जो मेरा ये AWS3 वाला जो कंटेनर मेरे OpenShift में चलेगा, वो उस यूज केस में चलेगा जब मैं AWS से S3 स्टोरेज AWS से ले रहा हूँ. करेक्ट. और उसके कॉरस्पॉन्डिंग कंटेनर मेरे क्लस्टर में चलेंगे टू प्रोवाइड द S3 स्टोरेज टू माय एप्लीकेशन और कंटेनर्स.
करेक्ट. यस.
राइट. तो वो चलाने के लिए मेरे को कुछ ना कुछ उसके कुछ कंटेनर चलाने पड़ते हैं उसको मैनेज करने के लिए. राइट. टू फुलफिल द स्टोरेज रिक्वायरमेंट ऑफ S3 टू माय एप्लीकेशन और व्हाटएवर द वर्कलोड इज रनिंग ऑन माय वर्कर नोड्स. राइट.
यस.
तो ठीक है. तो वो उसका ऑपरेटर बना के AWS ने पब्लिक किया हुआ है कि आपको अगर AWS का ऑपरेटर चाहिए तो आप यहाँ से डाउनलोड करके आप अपने क्लस्टर में चला सकते हो. राइट.
आई कैन नॉट से दैट ये ऑपरेटर AWS ने बनाया है.
नहीं, दैट इज फाइन. ओके, ठीक है. जस्ट
एक ऑपरेटर आपको बना के दे दिया बस. इसको आप एक पॉड में चला
और ये
मैनेज
बेसिकली एससी ऑपरेटर मैन्युअली होता है या ऑटोमेटिकली डिप्लॉय? ये S3 ऑपरेटर में मैन्युअली डिप्लॉय करना पड़ता है या ऑटोमेटिकली होता है अगर मुझे कोई कभी जरूरत रहती है तो?
इसका आंसर मैं देता हूँ आशीष. इसका आंसर सॉरी कौशल, सॉरी स्टॉपिंग यू. इसका आंसर जो आशीष आप क्वेश्चन पूछ रहे हो, करेक्ट मी कौशल इफ आई एम रॉन्ग. जो आपका क्वेश्चन ये है कि आप इसको लेट्स सपोज आपके पास एक आप AWS चाहते हो इस S3, तो आप फर्स्ट टाइम ये ऑपरेटर डिफाइन करोगे अपने क्लस्टर में. आप उसमें वैल्यू दे दोगे रेप्लिका 5, तो वो 5 कंटेनर मेंटेन करके चलेगा. राइट. तो अगर लेट्स सपोज आपकी रिक्वायरमेंट बढ़ती है कि मेरे और वर्कर नोड आते जा रहे हैं, मुझे S3 और चाहिए स्टोरेज, देन इट विल बी यू नीड टू इंक्रीज द कॉरस्पॉन्डिंग S3 कंटेनर एज वेल. तो वो आपको वो रेप्लिका उसका जो है बढ़ा के 10 करना, तो उसी टाइम आप इसी ऑपरेटर में चेंज करोगे और यू कैन इंक्रीज इट एंड कॉरस्पॉन्डिंग आपके ये कंटेनर बढ़ जाएंगे. कौशल, Correct me if I'm
you are saying it wrong. RC ये pod एक बना हुआ है. अब आपको pod की और requirement है तो आप RC में replicas बढ़ाते हो ना.
correct.
अब आपको अगर S3 और चाहिए, ठीक है, तो यहाँ पे जो आपने S3 का ऑपरेटर चला रखा है ना, RC तो एक ही होता है ना, तो S3 का ऑपरेटर भी एक ही होगा. तो आप इसमें डिफाइन करोगे कि आई नीड 5 S3 बकेट. क्लियर? ऐसे.
इसमें जो आपने अभी जस्ट रेप्लिका इक्वल टू 5 S3 बकेट लिखा और ऊपर रेप्लिका लिखा, इसमें दोनों में डिफरेंस क्या है?
डिफरेंस कुछ नहीं है. S3 ये रेप्लिका, ये एक्चुअली ऐसी कोई टर्म एग्जिस्ट नहीं करती है, इसे समझाने के लिए.
मैं भी आई थिंक मैं भी यही कह रहा था कि लेट्स सपोज अगर मेरी
कह रहे हो कि अगर 5 S3 बकेट चाहिए तो 5 S3 ऑपरेटर बनेंगे नए.
सॉरी नो 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 मैं रेप्लिका इज इक्वल टू 5 इज इक्वल टू 10 करने की कोशिश कह रहा हूं.
नहीं नहीं मनीष और कुशल, मैं एक एग्जांपल बताता हूँ. जैसे ना कि अभी समझो हमने VMware में टेम्पलेट बनाया RHEL 7 या 6 का. जैसे मेरी रिक्वायरमेंट बढ़ती है, जैसे अगर मेरा कस्टमर बोलता है कि मुझे 10 VM चाहिए, तो जैसे टेम्पलेट बना के तो यूजर जो VMware यूजर रहता है या एडमिन यूजर या ऑपरेटर जैसे दिया, अगर मैंने रिक्वेस्ट करता तो वो 10 VM अगर अप्रूव होता है तो वो ऑटोमेटिकली 10 VM ने क्या वो क्रिएट कर देगा, सेम एज अ ऑपरेटर है यूज. आप जैसे बोल रहे.
हाँ, ऑटोमेटिक करने के लिए सही बोला. ऑटोमेटिक वो VM प्रोविजन कर देगा ना.
हाँ करेक्ट.
हाँ, तो
जैसे
वही
मुझे
ऑपरेटर.
अगर 10 VM की तो ऑटोमेटिकली ऑपरेटर को इनिशिएट हो जाएगा और ऑटोमेटिकली वो क्रिएट हो जाएगा.
यहाँ पे ये S3 का ऑपरेटर क्या कर रहा है? ये सिर्फ और सिर्फ मैनेज कर रहा है आपके स्टोरेज को. ओके. और ये ऑपरेटर ऑटोमेटिकली आपके बकेट्स को डिप्लॉय कर सकता है, क्लेम बना सकता है, सब कुछ बना सकता है. ये ऑपरेटर नहीं होता तो आपको सब कुछ मैन्युअल करना पड़ता. क्लियर मनीष?
क्लियर. सो आई थिंक इट्स क्लियर. थैंक यू फॉर लॉन्ग.
इट्स ओके. जैसे यहाँ पे वी कैन टेक वन मोर एग्जांपल. मॉनिटरिंग है जैसे. ओके, इन द मॉनिटरिंग लेट्स से यू हैव द Dynatrace operator. Now this is just an enterprise tool actually. Okay, not open source. A lot of companies are using Dynatrace. So see, this Dynatrace one agent operator allow users to easily deploy full stack monitoring for Kubernetes cluster. If this deployment or Dynatrace one agent is not available, you need to deploy it by yourself every time. So someone has the idea and someone has created this operator and he has programmed it. Okay. So automatically, when you will install this operator inside your system, it will be running inside a container or a pod, and this will automatically create or deploy everything in the Kubernetes cluster. So basic installation, upgrades, full life cycle, deep insights, everything you can manage with this single operator. Clear?
Right. Kaushal, I think.
Now this Prometheus operator. Now see. What Red Hat is doing? Red Hat is not actually running Prometheus itself. Red Hat is actually using Prometheus operator inside the cluster.
Correct.
आपके पूरे OpenShift में ऑपरेटर ही भरे हुए हैं सारे.
Okay.
Okay. It is using Prometheus operator to manage Prometheus. It is using ELK operator to manage ELK.
Red Hat is has a partnership with the Prometheus, and they have developed that Prometheus and giving the support on that part, right? So they have. Yeah. Basically, they are providing the support on that, right? And
yes, provided by Red Hat.
Right.
Okay. Now, so the operator lifecycle manager is actually facilitates the discovery installation. So with the help of this OLM, you can install your operators, update your operators and everything. Okay. Now Red Hat in collaboration with AWS, Google Cloud, Microsoft launched Operator Hub. Who have launched Operator Hub, guys?
Red Hat.
Yes. Okay. So Red Hat has collaborated with AWS, Google Cloud, and Microsoft. Okay. It is not open source. Red Hat is providing you these features. Okay. And accessible at this. The platform is a public repository and a marketplace for operators compatible with OpenShift and other distribution of Kubernetes that include the OLM. Okay. Now, if your Kubernetes is not having operator lifecycle manager, you cannot use operators. So this is a functionality of Red Hat actually. Now, introducing the declarative architecture of Kubernetes. So the architecture of OpenShift is based on declarative nature. Most system administrators, you can read this book later. Okay, I can highlight the things where you perform actions that indirectly change the state of your system. Like you want to start, stop your containers. So in a declarative architecture, you actually change the state of the system and system updates itself to comply with new state. For example, with Kubernetes, you define a pod resource that specifies that a certain container should run under a specific condition. Then Kubernetes finds a server with the help of scheduler, and that can run that container under those specific conditions. Declarative architecture allows for self-optimizing and self-healing systems that are easier to manage than imperative architectures. So Kubernetes defines the state of the cluster, including the set of deployed application as a set of resources stored in the etcd database. Okay, so introducing the declarative architecture of Kubernetes. Okay, now means overall, if we see that OpenShift is using Kubernetes, that is the meaning. Okay, now these are just the heavy terms: declarative, imperative. Introducing the OpenShift control plane. So control plane is a master node. On that master node, the etcd database is actually running. Okay, and OpenShift configures its master node so that they are not scheduled to run end to user application pod. So OpenShift will configure its master node so that they are not schedulable to run end user application. Obviously, whenever we run actually any of the deployment, the replicas are never created on master node. They are always created on worker node. Why? Because on the master node, there is a tent applied. Okay. If you are applying any tent on some node, then scheduler will never schedule the pod on that node. Okay. So that is the concept of tent and toleration. Okay. Which is a part of scheduling.
Toleration, I'm not to get that part.
Let's say you have 15 worker nodes, Manish, and on 5 worker nodes, you don't want to run any of the pod. Now,
any of the pod means related to the control plane.
You don't want your scheduler to schedule any pod on those 5 worker nodes.
Okay, I think that okay. So the similar we have discussed in the Kubernetes that we need to don't to schedule that on that particular node 1. We see
you can coordinate.
What is that word used in Kubernetes?
In Kubernetes also you have concept of tent.
No, we have used different.
We have used cordon.
Yes. That's one. Same.
Cordon is a different thing. Tent is a different thing. Okay.
Okay.
If you are applying a cordon on a worker node, that cannot be bypassed. But if you are applying a tent on a worker node, that can be bypassed. Okay, that is the difference. Now,
no, if cordon means the master, my controller.
Let me give you an example. Let's say you have 3 worker nodes.
Right.
On this worker node, you have 200 GB of memory.
Correct.
On this, you have 32 GB of memory. On this, you have 64 GB of memory. Now, this is a very heavy system.
Right.
Now, this is a part of my cluster. Whenever I will create any deployment, if I'm giving replicas is equal to 3, scheduler can place the pod on this heavy system, right?
Right.
I don't want scheduler to place any pods on this heavy system. What will I do? I will coordinate. Once I have coordinate, the scheduling will be disabled over here.
Okay, and that's let's suppose both these 3 worker node are working live and already multiple containers running on that. After 10 days, you want to deploy 3 replica, means some container, and you want to put it on the 32 and 64 worker node only. So and before starting the deployment of increasing the replica, so can we do the cordon of that particular node and respective running container will working fine, right?
No, you are understanding it wrong way, in a wrong way. See, if you want to schedule your pod on this 32 GB and 64 GB of system, you can tell that scheduler. Okay. What I am saying that this is a very heavy system. I don't want my scheduler to schedule any of the pod on this heavy system for 10 days. Okay. How will I stop my scheduler? So what I will do, I will cordon it. If I am cordoning this node, then it will be unscheduled. So scheduler will always schedule the pod on node 2 and node 3, not on node 1. Why? Because it is unscheduled. It is out of service right now, according to the scheduler. Now, till here, are you getting the point?
Right. That is
fine. Now,
Yes.
let's say a client is giving you $500, or let's say a client is actually giving you a very heavy application to deploy, and that application at least need 120 GB of RAM. Now, you will create a deployment, Manish, right?
right.
And you will use this replicas equal to, let's say, 3. Now, these replicas will be scheduled on these two nodes, obviously, because this is unscheduled node.
Correct.
I want to use it. Now, one option is you can uncordon it.
Correct.
Let's say at the same time, some another person is actually deploying a very light application and he has given the replicas as equal to 4. If you have uncordoned this node, this would be available to all the applications, right?
Correct. Absolutely.
Correct. I don't want that. What I want, now let's say I have tainted this node. If you are tainted this node, this is also unscheduled. Scheduler will never run these 3 replicas on this node. It will only be scheduled on node 2 and node 3. But let's say some client wants to deploy a 128 GB of RAM application, then in the deployment, you will use a toleration and you will give the name of the tent. Clear? So you are telling your scheduler that for only this deployment, if inside your cluster, if there is some tent applied, then please tolerate that and schedule the pod on this. Now, at the same time, if someone is deploying a light application, okay, it will not be scheduled over here. Why? Because he is not using toleration. So tent can be bypassed, but the cordon cannot be bypassed. If you are applying a cordon on a worker node, if you want to schedule any application on that node, you need to make it uncordon. But if you are applying a tent on a worker node, then you can use a toleration inside the definition of the pod. Okay, so that will be scheduled on that node. Got it?
Kaushal, my one point is that what is the advantage of this toleration? Example, this can be achieved by giving the node name or whatever the we can say. I forget that.
Let's say you have 100 worker nodes, then how will you give the node names? I want to schedule this 120 GB of RAM application only on 10 worker nodes, and I only want to schedule only this application. I don't want to schedule any of the application on those 10 worker nodes because they are of a very high configuration.
एक कौशल वो जो अभी हमने पढ़ा था नोड लेवल नोट क्या होता है उसमें यार, वो क्या था वो
क्या यार, नोड सेलेक्टर
यस
Yes, node selector. You can use that. Okay. I'm
So
not
node
saying
select is
no.
the best way to do that, use this particular use case. But you do explain that that particular 128 GB RAM should be, if they want 3 containers on that specific type of hardware only. So I will give the one node selector naming to that all the high specific resources node only. I can
And
achieve
in the
that as
pod,
well.
what you will write then? That ignore this node if there is this label is applied like this.
Yes, node label. Yes, node label.
No, you cannot do that actually. Okay, that is not possible with node label. Okay. Let's say you have 10 worker nodes over here.
Correct.
Okay. These are of 128 GB of memory.
Let's first 3 is a 128, second 3 is 64.
No.
Yes.
Okay.
Okay. Fine.
Now,
And you given the node label as a
let's say you have given the node label over here, app colon heavy.
heavy. Correct.
What you will write in pod? Let's say you have given the labels like app colon middle, app colon high. Now, let's say you want to run the pods on the system which are having 64 GB of RAM and 32 GB of RAM. What will you do? You will give the label, right? Yes or no?
Correct. Correct.
Correct. Let's say you have 500 worker nodes, or let's say you have 100 worker nodes. Now, can you write 100 labels over here every time?
Can you explain this box again? Can you explain this box again?
I am saying that inside the pod, you are using a node selector. Okay, and you are using these two labels. Let's say you are not using this. Okay, I have just defined normally. Can my pod be scheduled on this 128 GB of RAM system?
Correct.
I don't want my scheduler to schedule any pod on these three systems. So inside the pod, I will give my node selector. Only schedule the pods on the worker nodes which are having this two labels. Okay.
Yes, it should be reside on these two type of node label.
Yeah. Now see, let's say you have 100 worker nodes, and on the 100 worker nodes, you have only one heavy system. And 99 are having different type of labels. Will you give 99 labels over here to restrict the scheduling on that one node? Obviously no, that would be too complicated.
No,
Okay.
you are saying that like I think that will not be a best recommended way to do the labeling on every compute. So that is not the best way, right?
Yeah,
Normally,
I'm saying that if you want,
what are you trying to do with tent? Tent is also you are giving specific to the number of computes as well, high level computes, right?
yeah, if you want to restrict the pod to be scheduled on the particular nodes inside your cluster, which are having very high configuration, you don't want to use them, then you can apply tent on them. Clear? So scheduler will never try to see these three computes. Scheduler will never try to launch any pod on these three computes. Okay.
I can say like that. I will give the okay.
Now, let's say one application is a very heavy application. You want your scheduler to schedule that application on these heavy worker nodes, then you will give toleration over here. So with the help of toleration, scheduler will bypass the tent, okay, and will schedule the application on these worker nodes which are having tent, okay.
So, Kaushal, I'm visualizing something. If you are saying that, if let's suppose you are giving the tent on one server, okay, and rest of the 9 server is having nothing, correct? If you are giving tent on in that YAML file, right? It automatically go on to the server 1, right?
Yes.
Okay. If you are not giving the 10, then it goes not going to the 10 part, and it will reside on the remaining 9, correct?
Yes, yes.
Okay. Okay. Let's suppose if I use node label tent as a node label tent, okay? Okay, so when I run this application as a one single container, so it will reside on that first server. Okay.
Yes.
Okay. If I will not give any node label, well, whether it will reside on the one or not.
If you are not giving any node label, then
Yes.
it can reside on all 10 servers. No, it can be
Or 10
scheduled
servers.
anywhere
That is the difference.
because you have
So
not
that is the
applied
difference.
10.
So that is the difference. So node label, for the node label, you have to specify the node label so that it can reside on that. If you are not giving anyone come on that part, right?
Yeah.
You got my point or not?
Yeah, I got your point. Okay.
Okay. So that is the difference of tent and normal node label, right?
Yes.
I'm right. So what I am describing, so that my understanding is right?
Yeah, that's right.
Okay.
Okay. Yeah.
Thank you.
Ashish, Nagi, are you clear with the tent and the cordon?
Yes, teacher. Yes.
Yes.
Nikki and Ashish, I think I'm asking all the question on your behalf, right? Right?
Yes,
No,
yes.
that's okay. Yeah. Now this is the architecture of OpenShift master node. Okay. Like in the Kubernetes, you have API server, controller, scheduler, etcd, kubelet, cryo. So OpenShift also gives you its API server, its controller, its core DNS. And OpenShift also gives you an operator which is called OAuth. This operator actually, this is a custom resource which manages the authentication. Okay. Who can log in into my cluster, what privileges the person is having, everything is managed by this API server, and at the backend it is using this resource OAuth. We will see the practical of that in the upcoming labs. Now, describing OpenShift extensions. So there are a lot of extensions, okay, a lot of storage plugins, network plugins, ingress, authentication plugins are there already available in OpenShift. And OpenShift also is a Kubernetes distribution that provides many of these components already integrated. Okay, like web console, image registry, these all are managed by operators. Okay, your web console is also running inside operator.
In OpenShift, you told that we are using Cryo, right? Instead of Docker, right?
Yes, OpenShift 4.5 is using Cryo. They are not using Docker now. Okay, Kubernetes will also remove the Docker. Okay,
Kubernetes also remove the Docker. Okay.
yeah, in the 1.23 version. Right now the version is 1.20. Okay. Yeah. After that, introducing the OpenShift default storage class. Okay. So OpenShift suppose stateful applications by offering a comprehensive set of storage capabilities and supporting operators. Okay, like the way we have discussed, S3 operator. Okay. So for example, if you install OpenShift on Amazon Web Service, your OpenShift cluster comes pre-configured with default storage class that uses AWS EBS service automatically to provision storage volumes on demand. Now this storage class is a concept of Kubernetes, guys. Okay. Users can deploy an application that requires persistent storage such as databases. OpenShift automatically creates an EBS volume to host the application data. Now, OpenShift cluster administrator can later define an additional storage class that uses a different EBS service tiers. So for example, you could have one storage class for high performance storage that sustains a high IO operations per second. Another storage class for low performance, means low cost storage. Okay, all type of storage classes you can create. Okay, and this storage class is a resource, okay, which actually dynamically provisions the storage. Now, introducing operators, we have already discussed so much things about operator. So they are the custom resource. They are defined in custom resource definition. Okay. Now, for example, an operator that manages a database server. Introducing the OpenShift operator framework. So you have two things: operator SDK and OLM. OLM is actually used to update the operator, install the operator, upgrade the operator, delete the operator. And operator software development kit is actually provides a set of Golang libraries and source code, which gives you the example that implement common patterns in operator applications. So you can take the examples from Golang libraries and source code and you can create your own operator. But for that, you need to be very good with the Golang. Okay. Now, because everything is designed in Golang, this is a programming language.
Go language, right? Go language, we call it.
Go language. Introducing operator hub. Now, there are a lot of operators which are actually used in OpenShift. OAuth, Core DNS, Web Console is running inside operator. Internal OpenShift registry is running inside operator. Monitoring stake means Prometheus is running inside operator. These are the operators which are already configured inside OpenShift. Now, exploring OpenShift cluster operators, so you can see that a lot of different type of operators are there: network, ingress, storage, authentication. This is written over here. Okay. Console, monitoring, registry, cluster order scaler, OpenShift API server, DNS, controller manager, cloud credentials. These all the things are actually running inside operators. They all are custom resource. This we will do tomorrow.
Sorry. Can you go on the resources part again? List of the resources. So
Here.
go down. Yes, this one. So you are saying that these are the operators.
Yeah, for network in the OpenShift, network is managed inside operator. Storage is managed by operator. Authentication is managed by operator. Console is actually managed by operator. Okay. So these all are the cluster operators.
Can you show this something example? What exactly? Can we log in your
Yeah,
setup?
I will actually show you the example in the second lab. Okay. We are actually going to do the practicals from second chapter.
Okay.
Okay.
Got it.
Now, one important thing I need to discuss with you guys: when to start your role. Because from tomorrow I'm going to do the labs on my system, okay, on my role. So when you want to start your role, because आपको भी practice तो करनी पड़ेगी ना, regular labs तो करोगे आप.
फ्रॉम सैटरडे, क्योंकि आपका क्लास होने के बाद ही हम प्रैक्टिस चालू करेंगे.
Okay. So from Monday मैं आपका role activate कर देता हूँ. So you will
Not
be
mine.
having 90 days.
Not mine. Yes, that is a concern for me.
Human.
Ashish, sorry, Kaushal, can I, from the initial 1 to 3 chapter, can I run on my that particular CRC to
No,
install on my
that is
laptop?
not
And
possible. No. Red Hat labs are only done on Red Hat predefined cluster. You cannot do it on CRC. You can do practicals by yourself, but Red Hat Labs would not be done over
I
there.
understand. No. I'm not expecting that I run on the same Red Hat setup on my
Yeah,
laptop.
you can run all the commands of OpenShift. Okay.
Whatever we running, what we are you're giving the lectures to run the RC DC file, everything. Let take an
Actually, see,
example.
CRC is a single node cluster. In that
Yes.
CRC, there are a lot of things which are not configured by itself. Okay. So you would not be able to use a lot of functionalities. Okay, which I will be giving or which I will be talking about in the lectures.
Okay.
You can only run basic
It's
commands
like
on
POC.
CRC.
It's like a POC, proof of concept, single. No?
Yeah.
Okay, I think I can. Okay.
Enough,
Can
guys?
you? Okay, understand. So I have my my official lab setup.